So we have question 7 from simple harmonic motion. I solved question 6, the last. In question 7, an archer is carrying out some target practice, and with his bow and arrow, he attaches an apple to a spring hung with a fixed support and set the apple to vibrate or oscillate with an amplitude 10 centimeter. The apple performs simple harmonic motion with a frequency of 0.625 Hz. Describe the conditions required for an oscillation to be simple harmonic motion. Like, what are the conditions for an object to perform a simple harmonic motion, or its motion is said to be simple harmonic motion? So the 2 points, this is a fixed answer, the structured answer. First point, the displacement is directly proportional to acceleration, or acceleration is directly proportional to displacement. And it is the second point is always acting towards the mean position, or you can also say that it is always directed towards the center. So the first point, acceleration proportional to displacement. And the second thing, it is always directed towards the mean position. Or object will have a tendency to move towards the mean position. Or you can also say that acceleration is force is directly proportional to displacement, and it is always directed towards the mean position. In part B, the diagram shows an apple on a spring. A and B are the positions of maximum displacement, and O is the equilibrium position. Sketch a graph how a displacement of an apple vary with the time. So how the displacement will vary with the time for an object which is vibrating or performing a simple harmonic motion, but it's of 4 marks. So how to score the mark? You have to label the axis as well. You have to label, because the information is given in the beginning of the question that it has a frequency of 0.62 Hertz, and the amplitude at which it is vibrating, that is equals to amplitude of the oscillation. The vertical oscillation amplitude is 10 centimeter. So first what we have to do, we have to label the points. As the amplitude is 10 centimeter, so we'll have +5, +10, +15. Then we have -5, -10, and -15. What about the time axis? So you have to first find the time period. Time period is reciprocal of the frequency. So 1/f. The frequency of the vibration is 0.625. So when we solve, we get the time period as 1.6 seconds. So if the time period is 1.6 seconds, what we can do, we can label the axis. Like we can have 0.8, we can have 1.6, we can have 2.4, and then we'll have 3.2. Because the time period is 1.6 means it will complete one, and it's a displacement graph. So the displacement graph start with the sign. So one vibration, we have to reach the maximum amplitude is 10, but we have to complete one vibration in 1.6, so half vibration in 0.8. +10 and -10, it will finish 1.6, and then +10. And -10, and it will complete in again 0.8. So this is a graph you have to sketch. Why it's so 4 marks? 1 mark is for representing a sine graph. Because like when the amplitude is, when the displacement is 0, it has like at the mean position, the displacement is 0. At extreme position, the displacement will be maximum. Then 1 mark is for getting a time period. 1 mark is for drawing a cycle in 1.6 seconds. And 1 mark is for labeling the amplitude. Is it clear, this one? The graph? How we know the graph is a sine? Why we draw a sine graph? Yeah, that's a good question. How you know it's a sine graph? Because if you see here, the apple is at position O. So apple is at its mean position. So if the apple at its mean position, what is the displacement? Displacement is 0. If the displacement is 0, it means the graph should start from 0. That's why we use a sine graph. So you can make a sine graph or you can make a minus sine graph. But if it was the same question was there, but the apple was not at position, the mean position, say the spring was stretched and it was at position B, then we'll draw a cosine graph. Because the cosine graph, the starting value is not 0, it is above 0, like any maximum or minimum, plus or negative, but not 0. So how we identify, we have to start, use a sine graph, because the apple at its mean position shown in the figure. That's why I have to make a sine graph, because sine graphs start with 0. Is it clear, this one? The next one, calculate the maximum velocity. Whenever you want to calculate the maximum velocity of object which undergo a simple harmonic motion, the formula is V equals omega A. That's a formula. And what is omega? If you don't know the omega, omega is 2 pi f. So we can say V is equals to 2 pi f into A. So 2 multiplied by pi, which is 3.14, times the frequency 0.625, times the amplitude 0.1. Because it should be in amplitude was given in centimeters, so we convert into meters. When we multiply, we get 0.393 meter per second. That's the amplitude of vibration. That's the speed, the maximum speed at which will vibrate. Then the archer fires an arrow towards an apple as it is oscillating. Explain at which position of the apple the archer has the best chance of scoring the direct hit. Like at which position you think the archer should aim so he will get a direct hit. Should he point towards O, or he should point towards B or A? So what is the best position? The best position is A and B. Why the best position is A and B? Because at position A or at position B, it will momentarily stop. Like here, it is vibrating with a maximum speed. Because at mean position, the object will have the maximum speed. So momentarily, the apple will stop at position B, or it will stop at position A. So momentarily, the apple will stop either at position A or at position B. So he has the best chance to hit the apple when he aimed at position A or in position B. So why he should, what should be the answer here? So which position he should aim? So either you can mention A or you can mention B. And what is the reason? Because the speed at A or B will be minimum, or the apple will be at rest or momentarily at rest at these positions. Over the time, amplitude of apple oscillation will decrease. Explain how the principle of conservation applies to this situation. A static question, a 3 mark. So how we can apply the principle of conservation of energy here? The points you will mention, first thing, the total energy. One point is, what is the conservation of, according to law of conservation energy, the total energy is same, but it transforms from energy transform from one form to another. So we'll mention the total energy remains same, but the energy transferred to the surrounding in the form of heat, or because there is a work done against the friction due to air resistance. So 1 mark is for mentioning the total energies conserved. The second point, what will happen? The energy is loss in the form of heat due to air resistance. And what is the reason for that? Because there is work done against the air resistance. Because there's a work done against the air resistance, that's why the energy is lost in the form of heat. So the structured answer for this type of question, in which, or you can also say the system is damped, loses energy. Another question, question 8. This question is about, like, we have 250 gram mass is there, which is vibrating a mass spring system. The spring is extend by 16.5 centimeter when the mass is added. The mass is then displaced further 3.2 centimeter vertically downward and released. The mass oscillate with a simple harmonic motion. State the conditions for a mass to undergo a simple harmonic motion. So what are the conditions for simple harmonic motion? The acceleration proportional to displacement, and it is directed towards the mean position. Calculate the maximum kinetic energy. How to work out the maximum kinetic energy? First, you need the speed, and from the speed, you can work out the maximum kinetic energy. How you can work out the speed? You have the formula that, because we need the maximum speed. So maximum speed is the amplitude omega A. This is and from this V, we will use a formula. Kinetic energy is half mv square, and we get the maximum kinetic energy. So how to solve? First we'll find the value for a K, because for a mass spring system, what is omega? Omega is under root K divided by M. That's a value for omega. So we need the K. How to work out the K? So F is equals to Kx. So K is force divided by extension. So force, the mass which we applied, that is 0.25 kilogram, and the gravity 9.81, that's a weight, divided by the extension. How to know the extension? It was 16 point, the spring extends 16.5 when this load is added. So what is the extension here? 16.5 centimeter. We convert that into meter. which is 0.165. So this will give us a value for K, which is 14.9 Newton per meter. After getting the value of a K, we can find the omega here, because omega is equals to K divided by M. So omega is equals to 100 K, which is 14.9. Why we are not including 3.5? Because uh, we don't know how much force is causing a 3.5 centimeter extension. Like the mass is then displaced 3.5 centimeter vertically downward. But we don't know what is the total force now. That's why. So we use 16.5 centimeter because we know the mass of 250 grams cause a 16.5 centimeter extension. But we don't know when a further 3.5 extension is there, how much, what is the total force now? That we don't know. That's why we did not include. So 14.9 divided by the mass which we attach will be 0.25. This will give us omega, and omega multiplied by the amplitude, because V is equals to omega A. V is the speed at which it is vibrating. So you can just substitute this value, or omega is equals to, after getting this omega, A is the amplitude of the vibration, just multiply them, you'll get the final answer. Is it clear, this one? How to work out the, like, you can use, you can also work out the time period, and from time period, you can work out, like, you just have to substitute the value. After calculating the maximum kinetic energy, the graph shows the displacement. Add to show a kinetic energy. Look, kinetic energy, actually, the graph for kinetic energy will be same like a speed graph. So displacement graph, which graph is this? This is a sine graph for displacement. So what will the graph for velocity? It will be cosine. So if the velocity graph is cosine, the kinetic energy is half mv square, which also vary with the velocity. So what change happened to the velocity? Same thing happened for the kinetic energy. But the kinetic energy cannot be negative. Like cosine can display, velocity can be negative, but kinetic energy is a scalar quantity, so it should always be positive. So when the displacement is zero, it will have the maximum kinetic energy because it will have the maximum speed. The maximum kinetic energy when the displacement is zero, then when it is at extreme position, the kinetic energy will be zero. Then again, the kinetic energy maximum, then zero, then maximum, then zero, maximum, zero, maximum, zero, maximum. So that's how the kinetic, why not negative? If this was a velocity time graph, then we will make a negative. But kinetic energy is half mv square. So even velocity is positive or negative, the kinetic energy answer will be positive only. Is it clear, this one? The graph for kinetic energy? The mass is submerged in water. The oscillation is, the mass is set into oscillation as before. How the water would affect the amplitude of oscillation? Look, now water will act like a damper. This water will absorb energy. So this water will act like a damper, like there's a resistive force or a drag force. And as a result, it will remove the energy. So how the marks are distributed here? One mark is for the water will act like a damper. That is one mark. And when it will act like a damper, the oscillation will be a damped oscillation. What is the meaning of damped oscillation? Means the amplitude will decrease. And when the amplitude will decrease because the energy is dissipated, removed from the system. So when the energy is removed from the system will eventually reduce the amplitude of vibration and eventually it will stop. So this water is acting like a damper for this. Is it clear? So these are some questions from simple harmonic motion, the exercise.